Hi, my name is Mackenzie Lawler, and I'm looking at the Moneyball application with the statistical analysis of women's lacrosse. Okay, so first a little bit about what inspired this thesis for me. I was a Division I athlete here at Robert Morris. I played lacrosse, and then I also coach as well. I have my own travel team in the summer that I'm the owner of, and I've always been interested in coaching, and that's something that's a career aspiration for myself. So after, I'm a big fan of the movie Moneyball, and once that came out, it kind of got me thinking with my dad of how could this be applied to smaller types of sports, and most specifically women's lacrosse, because that's where my interest was. If you're familiar with the movie, as you go through my presentation, you'll realize that in Moneyball, they looked at individual statistics. So one of the most famous ones was your on-base percentage. Whereas for this first analysis that I did, I looked at team statistics that would help an overall team winning throughout a season. So I broke up my research questions into 4 different categories. I had general questions, were just kind of basic statistics that could happen all over the field. They're more fundamental based. Offensive, mostly were focused around shooting, your attackers, how many goals you have per game. Defensive, we focused on the caused turnovers you could have, your fouls, and so on, and then also officiating, whether officials were statistically significant in the game. So like I said, this kind of breaks them down more specifically. My questions for general research questions included draw controls, which if you're not familiar with women's lacrosse, I know it's not very big out here in Pittsburgh, but draw controls would be like a jump ball in basketball or face-off in hockey. They happen at the beginning of every half and after every goal, so it's a way to get more possessions. Ground balls would just be any type of like 50-50 ball that's on the ground and either team could pick it up and add a possession. And then when I did my research through other sports, in basketball it's been a really big new trend to look at the number of possessions that a team gets per game, so I wanted to look at that for lacrosse as well. For offensive, I looked at your shots, also your shots on goal. I know myself as a player, we really focused on your shooting percentage, but you have to take into account what the goalie is saving and what are you just missing yourself as a team. Free position shots in women's lacrosse are similar to penalty shots. If you have a foul that's committed a certain distance away from the goal, you get a free shot that's 8 meters away from the goal. And then also looking at your assisted goals was my last offensive research question. For my defensive, I was looking at the number of goalie saves you have per game, free positions allowed, so how many times are you committing a foul that allows the other team to get a free shot, and then the number of caused turnovers per game. And then finally, for officials, I looked at the number of total fouls they call, and then I also looked at yellow cards. Yellow cards in women's lacrosse result in a 2-minute releasable penalty where you play man down on the field. So most of the it's assumed most of the time that those result in goals, and yellow cards, are a bad thing to have. So the sample space that I looked at, originally I wanted to watch all of the games, but due to time constraints, I decided to look at the box scores. So I selected 150 NCAA Division I games from last season. There was a total of 100 teams last year, 41 of them are my sample space. 34 of those 41 teams had winning seasons, and then 12 of the 13 conferences in women's lacrosse were also represented. Of my 150 games, 91% of them, the winning team was in the top 50, and then 49% of them were in the top 15 teams. The other thing that also influenced my sample space, some of the statistics I did, I had to go through the play-by-play of the game. They weren't in the box score, so only certain programs, most of the ones, luckily, who are win most of the time and were in the top, but only certain programs take those play-by-plays. So that also influenced my sample space a little bit. So these are just my basic descriptives of my data. I overall took 20 statistics, and once we get to my regressions, you'll see that my margin of win, or your margin of win at the half, was my dependent variable. And then I was looking at all of the other, your total shots, shots on goal, assists, and so on. So this just kind of gets a general idea of where the numbers lie within the 150 games. And this is just the second half of your descriptives as well. So when I ran my correlations, all of my variables were statistically significant to the margin of win in a game, except for these 5. So your turnovers, yellow cards, and then your man-up opportunities, shots, and goals. Once I realized that yellow cards were not statistically significant, it makes sense that the man-up opportunities, goals, and shots are also not statistically significant because those only occur in a yellow card situation. Then I ran a regression, or linear regression, to look at, well, these are my correlations, excuse me, sorry. So the first column tells you whether it's a positive correlation or a negative correlation. All of them are positive except for saves. So that actually means the more saves your goalie has in a game, the less you're winning by. And I kind of attributed to that of, most the games where teams would dominate and just hold the ball majority of the time, the other team's not really getting that many shots. So it kind of shrinks that margin down. And these are just the rest of the correlations as well. Same thing, you can see that all of them are positive except for most of the time the defensive statistics. So the more fouls you have, the less you're going to win by. Same with your yellow cards. And for the third column, anything that's less than that 0.05 would be considered statistically significant. So with my regression model, like I said before, I used a linear model. I used SPSS software in order to compute this. And with my 20 different variables, when I compared them with your margin of victory, it accounted for 85.9% of the variance, which is extremely high. So I was very happy with the data with that. And we'll get to my next tables, but my beta weights showed the predictor strength. So it kind of helps me rank which statistics are more important. And then I also passed all multicollinearity tests. So that just means that my independent events weren't dependent on each other. So this showed the statistically significant variables in my model. So that would be your shots on goal. Obviously goals make sense because you can't win a game without scoring. The ground balls, free positions allowed, and your margin of victory at the half. So the standardized coefficients, which are your beta values, tell you how significant or how strong of a predictor that they are. And then I still have the significance. And then my tolerance and my VIF levels are just whether or not they passed the multicollinearity test, and which all of them did. Something that we thought was interesting, similar to some of the other models people have talked about, margin of victory at the half was my strongest predictor for whether or not they would win a game, which was surprising to me. If you think of other sports like football or basketball, oftentimes teams can be down at half and come back to win. Whereas in my 150 games, I only had like 12, I think it was 12 or 13 games where a team won when they were down at half, which is extremely low. So once we broke, we did a second regression where I looked at my margin of win at the half. And interesting enough, assists showed up as statistically significant when you were just focusing on the margin of victory at the half, but they weren't significant for the margin of victory for the whole game, which kind of stumped myself and my advisor a little bit. We talked a little bit with my coach here, Robert Morris, of how, why that could be. Some attribute it to just the pace or the style. That could be a little bit of officiating as well, but that's hard to determine just statistically, not without watching the flow of the game. So conclusions, when I go back to my research questions that I had, the only ones in my sample space that showed as statistically significant would be your shots on goal, and your total shots, ground balls, and free positions allowed. And then just what does this mean in general for players, coaches, and officials? One of the biggest things I took away from this is officials seem to be doing their job and are not statistically impacting a game. It doesn't matter the number of fouls you have or how many penalties you have. So in that respect, for many of the coaches who spend a majority of the game complaining about the officials, if they're not statistically significant, you might want to rethink that and maybe coach shooting or your goalie saves or something that is a little more significant. And then for my further research, I personally am hoping to continue my career into collegiate coaching. So I'd be interested to take this just to a team basis, and instead of doing overall team statistics, breaking down each individual player and seeing what players are more valuable to you, that could help you with recruiting, that could help you with lineups and so forth. Any questions?